We have quite a complementary number of speakers, really, from entrepreneurial startup to industry and university. So please welcome Anita as moderator and this panel session.
Thank you, Thomas. So, good afternoon, everybody. My name's Anita Pabaka-Fox. I'm a senior researcher up at the University of Queensland. And my research focus has largely been around managing mine waste materials. So originally, I'm a geologist, but I specialised in how we actually manage mine waste here on Earth and how we can actually mitigate some of those really awful things we see in the news where obviously mining practices go a bit wrong and we have sort of big disasters like the tailings dam failures and acid mine drainage. However, when we look to the moon, what we can sort of start to appreciate is we're going to have a whole different set of challenges when we come to do things like mining. Now, I'm very fortunate in my career to spend a lot of time at mine sites, and I'm always fascinated by seeing the masses of infrastructure that they need to actually extract these minerals from the Earth. But what would this look like on the moon? What sort of technologies are we going to need to actually be able to achieve this? So I'm really excited to have this panel here today who can help us understand the challenges and how they're going to address these challenges with technology and planning. So let me first introduce everyone. So first we've got Dr. Carlos Espejel. Would you like to give a couple of sentences on who you are and your background?
Yeah, for sure. Good afternoon, everyone. So my name is Carlos Espejel. I'm actually a Mexican, Australian, now living in Luxembourg. And I actually did my bachelor's degree at the University of Queensland in mechanical engineering. Then I did a master's degree in mining engineering at the UNSW in Sydney. And then I did a PhD in strategic mine planning at UQ. And I just recently finished that last year. And at the same time, I do have 10 years of experience in the mining industry, where I worked for BHP, Anglo, and Glencore, doing valuation of deposits and mines and so on. And I just joined recently iSpace last year. And one of my main jobs there is as well doing the valuation of lunar deposits and future mine planning as well. And another of my roles is finding a connection between the mining industry, resources industry like oil and gas, and the space industry. And yeah, that's a bit about me.
Thank you very much. Next we have Bohan Deng. Would you like to introduce yourself, please?
Hey everyone, I'm Bohan, and I'm currently a student at UNSW, where I'm pretty heavily involved in lots of space engineering projects as part of BlueSat. And I'm also the CEO and co-founder of a lunar ISRU startup called Sperospace. It's a very recent development, and I hope to share some of the stuff we're going to do. Thank you.
Thanks very much. And finally, we've got two representatives from the Nova rover team. We've got Henry and Daniel, so please introduce yourselves.
Hi everyone, my name is Henry Lowry and I'm the current team lead at Nova Rover. We're a student team from Monash University, and on my right here is Daniel Ricciardo, not the F1 driver, but the science team lead from our team. So he's in charge of the subsystems which are involved in taking a sample of dirt from the ground and analysing it for life, essentially. We'll touch more on that later. But so we build Mars rovers to compete in university competitions, and we're hoping to attend our second in May this year.
Excellent. And do you want to add any words? Or?
Henry sort of touched on everything. Yeah, so we're all uni students from Monash University, and we do build Mars rovers, which is very exciting, and we are hoping to return back to America.
Excellent, excellent. So let's kick off now with Carlos. Carlos is going to give us a presentation on the resources that we actually have on the moon. So Helen touched upon this morning, which was great. So he's going to follow on from what she was saying there. Thank you, Carlos.
No worries. Okay, I'm going to test this first. There we go. Okay, so this presentation is going to be on lunar resource utilization. Now, we don't really like to call it space mining or lunar mining. Actually, we're going to be doing some resource utilization over there. And yeah, we believe that the only way to do this will be by working together between the industries and governments, of course. I forgot to mention, but I'm actually based in our Luxembourg office. Okay. That's just a bit of the agenda of the topics we're going to touch. But let's start with the moon and its dormant potential. So as we know, well, the moon is our closest celestial body. It's around 400,000 kilometers from Earth. As we heard before, it's maybe around 4.5 billion years old. And as well, it kind of takes us to go there, to get there around 4 days. Well, that depends on the propulsion system that we use, of course. And so far, it has been visited by 3 countries, Russia, the US, and China, and very soon by your friends from Israel, that they're on their way right now. And so far has been visited by 12 people and all American. Well, but we actually do know way more about the moon, and it's pretty exciting. And this is that the moon is actually rich in resources, as we just heard before. And we know these through the different missions from NASA, ESA, JAXA, and the Indian Space Agency. Now, we do have now resource maps. Now we kind of know the distribution of some of these elements like iron, magnesium, aluminum, calcium, silicon. At the same time, we know that there's plenty of thorium, uranium, potassium, phosphorus, rare earth elements. At the same time, we know there is titanium and high abundance of sodium, hydrogen, oxygen, and other volatiles around the moon. But the most exciting discovery is that on the north and on the south pole of the moon, well, there's water, right? And we actually last year got the actual location of these water deposits. And now we know that there is anything between 3 and 6 billion tons of water. And this is only on the surface on the moon and on the poles. Why the surface? Because so far the spectrometers that they have been using, they are only able to read just the first millimeters of the surface of the moon. And yeah, there's 3 to 6 billion tons of water there. But why is water so important? Well, besides being water, and our astronauts will be using it in the future, well, if you split water in hydrogen and oxygen, you got rocket fuel. Now, one of the biggest rocket companies in the world, ULA, United Launch Alliance, which is made of Lockheed Martin and Boeing, they actually said, we'll pay $3,500 to anyone that can deliver fuel in LEO, which is low Earth orbit. And we'll pay $500 to anyone that can deliver fuel on the moon. So with these numbers in mind, obviously many companies and entities started doing their numbers. Among those companies, it was us. And about the entities, well, it was the government of Luxembourg. And they actually came up with a really interesting study, a socioeconomic study on space resource utilization, together with ESA and PwC. And they came up with some really interesting results. And among these ones is that space resource utilization is a positive economic model, and that we can actually make around 170 billion euros on the first 27 years of this new economy. And this is starting from last year, and this is actually a present value, so discounted. And not just that, but that you can actually create around 845,000 to 1.8 million full-time employees. At the same time, not just these, but the companies that will use this fuel, they can make a savings of around 135 billion euros. Now, from this new space economy, we know there's going to be a lot of technology that will be developed around this, and therefore they also estimated the spillovers of this technology. And they estimated that this new spillover of technology will have a value between 54 and 135 billion euros. And part of this study actually took into account the moon, asteroids, and even the recycling of space debris. However, they concluded that we should start with the moon for obvious reasons. It's the closest one, and that we should start with water at the same time. Now, the next question is, well, is just ULA wanting to buy fuel? Who else is actually willing to buy this fuel? And there's another really interesting report called the Commercial Lunar Propellant Architecture, done by a number of entities and universities. And they actually said, well, there's actually a number of rocket companies that are interested in getting fuel now and in the future, and that we will need this fuel in different orbits, in LEO, in GEO, and different Lagrange points, and so on. But how are we going to achieve this vision? Just obviously if we work together, the space industry, the mining industry, oil and gas industry, equipment industries, and of course the governments, towards the one vision of lunar resource utilization. And we can follow some very simple steps. The first one in the industry is we can start by sharing our successful technology and know-how. As we know, there's a lot of technology that the space industry has developed that now can actually be used in the mining industry or other industries. And at the same time, there's technology and methodologies that the mining industry has developed that now can be passed to the space industry to go towards lunar resource utilization. Now, at the same time, we need to start sharing unsuccessful stories, mistakes, and lessons learned. There's a lot of disasters that have happened in the space industry, like the Apollos, the space shuttles, and so on, and that can be passed now to the mining industry in the form of standards. Now, at the same time, obviously, we in the mining industry have learned a lot in the last hundreds or thousands of years, and we don't want to make those same mistakes in space. We need to learn from those. For instance, we do not want to have a tailings dam on the moon, right? Now, at the same time, this brings the opportunity to co-develop together the space industry, mining industry, on technology that is of interest right now. And I will touch on this just a bit later. Now, a very important part of this equation is the governments, where they really need to be active on policy making, tax incentives, funding schemes, subsidies, and so on. And the two governments that have been pretty active on this is the government of Luxembourg, and therefore my entire work right now is funded by the government of Luxembourg, and the US. And there's other countries that are following actually on this. Now, we also believe that the governments can be and function as an anchor market where they can be the first customers of propellant or fuel for space, and all of these can create a new industry for a new market. Okay, but if we want to explore or use the resources in space, we need to really know our moon environment. And what do I mean by this? First, obviously, we have no atmosphere, so no oxygen, so we cannot really use internal combustion engines, for instance, unless you want to bring your own oxygen, but that's too heavy and therefore expensive. We know the temperatures can vary from 127 degrees, pretty hot, to minus 238 degrees, pretty cold. And at the same time, a lunar day is around 13.5 Earth days, and therefore the night is 13.5 Earth nights, which is pretty long, so we need to create technologies to survive the lunar night. At the same time, we know that the surface of the moon is quite hard and abrasive. I actually recommend you to go to YouTube and have a look at the videos of the Apollo astronauts with the drill bouncing on the moon. It's actually pretty funny. And the gravity of the moon is 1/6 of Earth. Now, what I want to say by this, and this is that we need to develop completely new technologies, completely new methodologies, but these at the same time give us the opportunity to co-develop technology that we can use now in the benefit of the mining industry and other industries. Okay, so this next slide is an invitation to co-develop, again, on technology that we can use right now on Earth, on the mining industry and for the space industry. On what? On exploration, mining, and processing. On exploration, we can co-develop together technology like for elemental analysis through sensing technologies, for remote sensing, on-site sensing. On the mining side of things, on smart and efficient systems, for instance, robotic drilling, plasma drilling, artificial intelligence, sensor-based ore sorting, autonomous navigation, 3D printing for maintenance, that's a big one, so on. And in processing, the very needed waterless and power-efficient systems, which we will need in space as well, for instance, dry processing, and extraction of iron with hydrogen, and so on. Well, I'm going to share now with you guys a bit of the iSpace or roadmap towards lunar resource utilization from today to 2040. And first, in the next 2-3 years, pretty much we're looking for partners to co-develop technology together, and partners that want to explore the moon with us. At the same time, in the next 2 years, we're going to be testing our transport and exploration technology, which I'll share with you in the next presentation. And at the same time, we are actively working with the UN around the whole exploration and mining licensing and so on. Now, from 2022 to 29, we're going to be doing some large exploration campaigns, not just for water, but for other resources. And these two define the resources, define the deposits with remote on-site sensing, sample collection, drilling, coring, and so on. We actually need some drilling systems, and I was looking at that one. Looks pretty attractive. And the next one, we're going to be doing large pre-feasibility and feasibility studies, obviously on space resource utilization. And we're going to be doing pilot testing on mining, processing, and refining technologies. Now, we believe by 2030, we're going to start using, in a very strategic way, the lunar resources as creating propellant for, not just for rockets, but for satellites as well. We're going to be starting using the lunar elements and resources for infrastructure, equipment, and electronics, and why not nuclear power for lunar services and the industry. So we believe that by 2040, we can now have a first human settlement, call it Moon Valley, Moon Village, but only if we work together, private industry and governments. Now, just some quick conclusions. First, the moon is rich in resources. Water will be the opening door for this. 2, space research utilization is a multi-billion attractive business. And a new race to the moon is on, and I'll show you more about this. And the next one, that industries and governments need to work together. Now, I think I have one more slide. Yeah, OK, I'll share something with you guys. This is one of the work that we're doing at the moment in iSpace, and not just by ourselves, but with other entities, universities, and governments. And this is that we are working on the first lunar standard code. As we know, in the mining industry, we have the JORC, the Joint Ore Reserves Code, and the NI 43-101 from the Canadians. And why is this so important? Because we needed to be able to report lunar exploration results, reporting lunar mineral and volatile resources, and at the same time, reporting lunar ore reserves. And yeah, and this is going to be called the LORSO 101 so far, or Lunar's Ore Reserve Standards. And actually, next week, I have a number of meetings in UNSW and Queensland regarding the first lunar standard code. And this is it. Thank you.
Fantastic. Thanks, Carlos. That's absolutely fantastic work you're doing, and I'm really excited about that code, so be keen to see how that goes. Let's move on now to Bohan. Thank you. He's going to use the lectern and mix things up a bit.
So that was a really great presentation by Carlos, and it's really great that what I'm going to be talking about is going to lead straight on from that, pretty much. So the question I'm addressing today is, why should we mine the moon? Because that's a very important question to ask. So quick introduction myself. I'm currently a fourth-year aerospace engineering student at UNSW, and I'm CTU at BlueSat, UNSW, which is Australia's oldest and biggest space project society. And I'm also the CEO and co-founder of a company called Sperospace, which aims to make moon missions cheaper and safer. So a bit about BlueSat first. So it was founded 20 years ago to provide students with real-world experience in space engineering. Since then, it has grown and has diversified its project. So as you can see, there's some examples here. First example is very similar to what Nova Rover team has right there. So we also competed in international competitions, the European Rover Challenge. We also have a CubeSat development team, which is aiming to launch a biological payload within 2 years. And also a high-altitude ballooning team, which is working on a contract with NATO for developing a radar platform. So why have a startup right now? So the question to that is, or the answer to that is because the Moon Race competition got announced. So who here has heard about the Google Lunar X Prize? Hands up. Right, so many of you would know that iSpace was one of the finalists for that competition. And that competition has ended, but in its place, a new one has popped up. So it's backed by ESA, Airbus, Blue Origin, among some other names, and there's also even more organizations talking with it. I know the Australian Space Agency wants to get involved. And what it does is it supports startups who are working on ISRU technologies. So us, specifically, we're working on the manufacturing stream. So what are the problems of going to the moon right now? There's two main ones which affect all missions, which is cost and distance. Yes, the moon is the closest celestial body to the Earth, but there's still a significant time frame, much more than the time needed to send something up to the ISS, for example. And the cost of launching anything to the moon is very, very high, at more than $1 million per kilo. So how do we solve this? Mining and manufacturing on the moon using local resources solve this. So there's around 3 steps involved if we abstract it a lot. So first step, you have, before that, of course, we have exploration. But first, you have gathering the local resources, which is mostly a robotics process. Then you have the actual processing of the regolith, if you want to extract anything useful out of it, unless you're just going to use it directly for manufacturing. And finally, you have the manufacturing part. So right now, the market gap, so to speak, is in the processing technology. There's significant work done in robotics as well as metal 3D printing, which is quite an established technology these days. So how do we plan to do the processing? It's really great that iSpace touched on it briefly, but the core part of what we're doing is we're basically adapting an established process called hydrogen reduction for space purposes and combining that with metal 3D printing. So using basically readily available hydrogen and metal oxides on the moon, through reduction process, you get water and metal powder. Metal powder can then be directly sold to customers or 3D printed into a part first, and the oxygen involved the oxygen that is extracted is also a valuable byproduct as fuel or life support, which Carlos mentioned earlier. So of course, why now? It's because right now there's a lot of stuff going on with the moon. There's basically a convergence between industry and governments around the world on it. And the first wave, which is the lunar landers and rovers, have been progressing over the past 10 years or so. So that's more or less established. So as you can see, there's a commercial lander going to be landed on the moon soon, as well as many others scheduled over the next few years. The next step after that is the payloads and support systems involved in demonstrating technologies. And some other in-situ use cases that was touched on. Here in Australia, for those who aren't aware, there's also another water kind of mining research project at UNSW called the WILD project. And some other useful in-situ manufacturing is in manufacturing solar panels with electronics, and also, as mentioned earlier, doing structures. So what's important about all this is that combined with the new generation of rockets that comes up, you have much lower cost of access to space. So what this brings me on to my next point, which is how does this compare to other developments of industrial ecosystems? So the first example is in the railway systems. So during the 19th century, the railway system basically fueled the Industrial Revolution by lowering the cost of access of transportation of goods and services across basically a continent. And more recently, you see the app ecosystem that has spawned out of the smartphone development. So 15 years ago, there was no like app ecosystem. Nowadays, it's worth trillions of dollars. What does this look like for space, though? So this is the vision proposed by ULA about what is called the cislunar economy, which is defined as basically all economic activity between the moon and Earth. And one thing important to note here is that you have asteroid mining and moon mining, and the two are actually quite complementary because they each have their own advantages in different areas. What's the market size? It's an important question to ask as a startup because it is basically a commercial entity. But for one, the Bank of America projects that additively manufactured parts in space would be worth $4.7 billion by 2027. And also, UOA projects the cislunar economy to be worth $2.7 trillion by 2045. So this includes things such as mining, manufacturing, habitation. And then there's also Jeff Bezos, who has the vision of basically moving all heavy industry off Earth, which is very interesting because it is actually quite directly related to the environment topic touched on earlier. Because while there's a lot of ethical considerations when it comes to mining off-Earth bodies, one strong point in favor of it is that it replaces terrestrial mining, which will always damage local living ecosystems. So here we have some cool pictures, which is what does cislunar manufacturing allow, right? So all the stuff you see inside, not all the stuff, obviously, but a lot of the infrastructure you see in science fiction becomes possible because when you're able to manufacture in space, you're no longer confined by payload and size limitations. So if you look at the ISS, unfortunately, I do have to say, I do find it a bit ugly because it's just a lot of modules strapped together. But if you have manufacturing in space, you're no longer constrained by those same limitations. And another thing to note is that a lunar space elevator is totally possible because of the lower gravity on the moon compared to Earth. So we could make it using current materials, as long as we can manufacture the parts locally.
Enough of that commercial side, though. How does it actually benefit humanity? So one of the good things about having the infrastructure in place in cislunar orbit is that you can launch exploration missions deep into the solar system for much lower costs. So to the left, you see a history of basically all the exploration missions set out in the past. And you look at those little probes and satellites, and you wonder, these probes and satellites, they have equipment that is extremely limited in weight, so often just a few kilos. They run on a couple of watts, extremely limited in power, and sure, they do a lot of great science with it. But imagine what you could do when you have tons of equipment doing that same mission. And then you have colonization. So many people regard the moon as a stepping stone when it comes to testing technologies for use further in outer space. So that vision that was provided by SpaceX, you look at all those structures, could you imagine bringing all those structures from the Earth to Mars and how expensive that will cost? That's pretty unfeasible economically, which means that ISR technologies for using local resources has to be present to be able to do that. And another thing which is really cool is that the first speaker was talking about one of her favorite songs about the moon. And I have one I quite like myself. So anyone here know Fly Me to the Moon by Frank Sinatra? Right? I think it fits perfectly with my talk. So for those who don't know, this is how it goes. Fly me to the moon, let me play among the stars. Let me see what spring is like on Jupiter and Mars. Thank you for listening.
Thanks, Fern. I've got science in a song there, so that was excellent. Let's now move on to our next speakers, the NOVA rover team. So Henry and Daniel, if I'd like to invite you to speak. Thank you. Yep.
So, hi everyone. It is our absolute pleasure to be here with you at the Forum on the Moon. And we'd like to take the next few minutes to describe what we do, what we've achieved, and how our work might be applicable to mining and robotics on the lunar surface. Although much of our research and work is conducted with the Martian surface in mind, many of the techniques and knowledge gained is useful in this lunar context. Cool. The NOVA rover team was formed by 5 students out of a garage in Murrumbeena at the start of 2017. We've now grown to 33 Monash students who collaborate to build Mars rovers to compete at the University Rover Challenge, or URC for short. We encompass a wide range of disciplines ranging from geology and biochemistry to mathematics and aerospace engineering. Behind me is a picture of some of our team out on a field test in April 2018 with our 2018 competition rover, affectionately known as Rovi. We have our 2019 Rovi over on the right-hand side of the stage. Please approach us at any time during the lunch break or after this talk. We'd love to tell you more about it. So the URC is comprised of 4 tasks. The first 2, equipment servicing and extreme retrieval, rely on the dexterity of the robotic arm as well as the maneuverability of the rover's chassis to complete tasks which simulate assisting an astronaut on an extraterrestrial. The third task, autonomous traversal, is quite self-explanatory. The rover has to autonomously navigate to a set of GPS coordinates which approximate the location of a visual marker. Onboard computer vision then has to locate that visual marker to a tighter threshold. The science task is the last task and is what is most applicable to our applications today. The science module, at least part of it, of the 2019 rover is fitted on the front of the rover over there, and so that makes up the majority of that task. So it requires subsurface drilling to acquire a sample of regolith, which is to be tested for extant or extinct life. These tests are to be done on board the rover, and our team uses a variety of spectroscopic analyses to do this. The URC is the most technical university rover competition in the world and attracts the most talented and driven student teams. So in March 2018, we were notified that we were successful in our bid to compete in the 2018 competition. This qualified us as the only Australian team and only team from the Southern Hemisphere competing in the 2018 competition. We are absolutely ecstatic to receive this news, being such a young team, only formed a year and a few months before that. We were able to finish in 14th place out of a total of 96 teams, which has given us the drive to continue our efforts and perform even better this year. The team has been hard at work over the past 7 months, designing, manufacturing, and assembling the 2019 rover that you can see on my right. We are currently awaiting the results of our 2019 System Acceptance Review, which basically decides whether we will be attending the 2019 competition. So I'd like to now show you a few clips of the 2019 rover doing its thing, doing some skids and things like that. After the video, I'll throw over to Daniel, who will speak more about extraterrestrial subsurface drilling techniques and technologies. So fingers crossed this works. Oh. What do we think? Have we got someone up the back who can click play on a video? Fingers crossed. Perfect.
Very dramatic. I love it. Okay, so I'm going to be tying that all together about why is this relevant and why we at today's talk. So I'm a big sci-fi nerd, and I love reading sci-fi books and seeing sci-fi movies. And I think this book by Andy Weir, Artemis, and the lovely movie Moon is really topical because they explore in amazing detail mining, exploration, and basically setting up colonies or establishments on the lunar surface. And this is really interesting because they go into a lot of detail, and they even show lovely photos and videos of large autonomous rovers, or these are harvesters. And being a nerd and being a part of a rover team, rather than being lost in the wonder of it, I broke it down and I said, okay, so what can these rovers do? And they require basically four key aspects. They need to be autonomous because they are on the lunar surface, so if something goes wrong, or we can't really rely on an operator to drive them constantly. They need to obviously have some sort of mining capability. So this may either be geographical field mapping, using like ore exploration, looking at the lunar surface about where the best place to go harvesting is, or of course using large drills or harvesters to sort of get resources out of the lunar surface. Then of course it needs to be robust. The lunar surface is extremely hostile. Much like the Martian surface, there are large obstacles, extreme terrain, ultraviolet radiation, really corrosive and abrasive dust that is going to, over time, cause these vehicles to decay. So they need to be robust, and we need to be able to rely on them to survive long periods of time. But at the same time, they need to be highly specialized. So anything we build on Earth, those large harvesters you see in like ore mines all over the world, those are specialized to that environment. Much like the rover we've made is specialized to the Martian surface. If we send that to Mars, it's not going to last a very long time because it's specialized to the human surface, to Earth, because we are simulating the Martian environment. So they need to be robust, specialized, some sort of mining capability, and autonomous. And luckily, these are the categories or the tasks that are expected of all teams competing in the University Rover Challenge. So this was the competition rover that we sent over to America last year. It is somewhat robust and somewhat specialized, but it was done after a year's worth of progress. So on the top, you can see the robotic arm, and that was the manipulator and end effector we used to sort of interact with the environment. And this was the scientific payload that we attached to the front of the rover, and although it's not specific to mining, its main task was to look for biosignatures and to look if there was any presence of extant, so previous or extant, which is currently living, or extinct life. But it is transferable because we actually designed and built our own holostem auger, which the main goal of it was to look at lithostratigraphic profile, or just like how the soil changes over time. And through that column, we can determine how the environment has changed over time, and also what sort of sedimentology, what sort of resources are available beneath the surface. This was in one of the papers that we wrote for, or concurrently by developing the system. In the top two images, you can see drill holes done by the Mars Curiosity rover. And then in the bottom two holes are the ones that we made using the rover last year. And one of the things I like to do at talks is to say which one was made by the Mars rover, which one was made by our rover. And it's exciting because sometimes people get it mixed up, and it's unique knowing that a bunch of students can make a technology that is rivals sort of NASA's technology. And on the left, you can just see the sort of different components that we used in the drill. And yes, that is a hand drill that we sort of cut the handle off from Bunnings. Being a student team, you do need to be innovative and creative. We used a lot of zip ties and a lot of duct tape. So this was actually one of the student projects. Yes, do. So one of our students was actually developing a Raman spectrometer, which essentially uses light to learn about the different structural properties of different objects. And the main goal was to put this Raman spectrometer on the rover and then give the rover a capability to determine what mineralogy was around it. And from that, you can look at different biosignatures, such as different minerals that form precipitously through water being there, which means there's a possibility for life. Or you can, of course, transfer that to looking at different minerals that would be essential for mining and sort of developing an industry on the lunar or Martian surface. Then, of course, going back to those 4 key points that I talked about, the rover does need to be autonomous, and if someone's required to drive the rover and make sure, oh, there's a big rock over there, I need to avoid it, the rover last year and this year, we've actually developed an autonomous protocol that it knows when it is about to go over a steep incline. It knows if it's about to hit a big rock. It is self-sufficient to some certain degree, and we can leave it by itself and perform certain tasks. And of course, this is the 2019 rover. And if the teaser video wasn't enough, we are happy to pronounce that the 2019 System Acceptance Review video that all teams must submit to be considered for the competition, we submitted midnight, I believe. Nice little deadline. So if you would like to see more about the rover, hear more about all the different subsystems from science, electrical, autonomous, software, chassis, there's a 5-minute video on YouTube. Don't check it out right now, but when you do have the time, just type in Nova Rover Team 2019 SAR. Just a quick little plug, we do have a website, Facebook and Instagram, so if you're feeling inclined, go ahead and check us out. Thank you very much for listening.
Thanks, guys. That was fantastic. We're going to hand back over to Carlos now, who's going to talk to us about the business case for mining on the moon. So thanks, Carlos.
Thank you, Anita. Okay. We are waiting for the presentation. There we go. Okay, so on this presentation, I'm going to be sharing more about iSpace as a company and about our transportation, or lunar transportation and exploration technology, and a project that we call Hakuto-R, and I'll share more about this one. So that's the agenda. I'm going to first start by giving you some space news, which there's a lot of exciting stuff happening at the moment. I'm going to share how we started as a company, a bit about our technology and the project Hakuto-R. Okay, in terms of news, there's a lot of stuff happening in space at the moment. And among those exciting things is our friends in China, where they just landed earlier this year on the far side of the moon. I just would like to say that it's not the dark side of the moon. I think the dark side is a song from Pink Floyd, I think.
Are you going to sing?
Right? No thanks. I know the song, but next time. And yeah, so they landed on the far side of the moon, and they're not actually shy about what they're doing. They're looking for resources as well, amongst many other things. And as well, our friends in the US, they just announced the 9 companies that they will be using to send payloads to the moon. And they actually put $2.3 billion on it, and we're happy to share that we are one of those 9 companies that they selected. At the same time, our friends in Japan, in JAXA, through the Hayabusa 2, they just got an asteroid, and not just got an asteroid, but they actually shot at it, grabbed the sample, and now they're actually on their way back to Earth. I just hope they're not bringing anything strange. I'm joking. And as well, our friends in Israel, through the first private company called SpaceIL, and they're on their way to the moon right now. Last week, they actually launched with SpaceX on a Falcon 9. And yeah, they should be landing on the moon somewhere in April. This is pretty exciting because we were working with them. And another news that we would like to share is that we in iSpace just won a project with ESA, the European Space Agency, where we're going to be exploring the poles of the moon for water and mapping those resources. Okay, iSpace. So how did everything started for us? And as they just shared before, well, we started with the Google Lunar X Prize, right? And this contest, well, they were like, okay, you guys need to build a lander, a rover, get to the moon, land on the moon, deploy the rover, take some high-definition pictures, and send them back to Earth. Easy, right? And out of those 34 competing companies, there were 5 finalists, and we're happy to share that we were one of those 5 finalists. However, the contest took too long, and there were some problems with the launching systems and lander systems, and that's how we actually decided to build our own lander. But at the end of the competition, I mean, it got canceled. We were like, well, we actually have a pretty cool rover. We have a pretty cool team, and we have a great vision. So with that, we kept going, and we actually managed to raise 80 million euros in a Series A funding. We broke the record of Series A funding in Japan, where we got funding by the biggest banks in Japan and companies like Suzuki and Japan Airlines. And with that, we became a private lunar exploration company, where we have now more than 70 people from more than 14 countries, and we got 3 offices. We have an office in Luxembourg, that's where I'm based. We have our headquarters in Tokyo, and we even have an office in NASA in the Ames Research Center. Now, it's all of us working with one vision, and this vision is to expand our social and economic sphere to the moon. And with this, I would like to share a video of our vision.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
So as you can see, we all here in this room have the same vision, which is expanding to the moon and further. right? Now, we in iSpace, we know that before the Moon Village or the Moon Valley, there's a series of steps that need to be taken and technologies to be created. Now, within iSpace, one of those first steps, we call it the Hakuto-R project. Now, this project is made of M1 and M2 missions, which is an orbiting mission and a landing mission, and I will take you to those 2 missions through the next video. So we're really excited to announce that we signed a contract with SpaceX, where we already paid for a flight. We have a scheduled flight for the second half of next year, where we're going to be flying on a Falcon 9, and first we're going to be orbiting the moon. And then we're going to be doing exactly the same in 2021, where we're going to be orbiting the moon, but they're going to be sending us to GEO first, geostationary orbit, and from there with our own spacecraft, we're going to be traveling to the moon. And this through our lander. So we are planning to do a soft spot landing on the surface of the moon. We're right now narrowing exactly where to land, but we have some pretty good candidates. Now, after the soft landing, we're going to be deploying 2 rovers. These rovers will have a number of instruments. We already have instruments on the current rover, and we're defining on the next instruments specifically to map resources on the moon. Now, inside the main rover, there's a tethering rover, which is a smaller one. And the main purpose of that rover is to go into those difficult terrains inside craters or skylines that were mentioned before. And this is pretty much happening in 2021. And this is what we call the Hakuto-R project. So, speaking about SpaceX and Blue Origin, as we know, they're doing an amazing job, a great job on the launching, on the commercially available launching systems. Now, in iSpace, we're looking at the next part. We're looking at the transport part to the moon, landing on the moon, and exploring resources on the moon. And in future, as well, building refueling stations in different orbits and Lagrange points between Earth and the moon, and other orbits and Lagrange points between the moon and Mars, and so on. Okay, and again, we're planning to do this through our signature technologies, which is the lunar lander, which so far can carry 30 kilos of payload, and our lunar rover, now, which so far is just 4 kilograms. Now, because I know this is a robotics talk as well, I would like to share with you a video that we don't really share that often, but today we're going to share it. And it's about some of the technology behind the rover.
Hakuto's Lunar Exploration Rover has been developed with a fully optimized design to achieve the mission. Launching the rover costs more than $1 million per kilogram. Therefore, mass is an important consideration. Hakuto has developed an ultra-compact and lightweight rover. The rover includes various commercial products for weight and cost reduction, all of which have passed environmental testing for space. Communication is the lifeline of the mission. Hakuto's hybrid communication system enables both long-distance and high-speed communication. It is carefully designed to adapt to packet loss and delays. Carbon fiber is used to construct the body of the rover. To withstand the enormous vibration of a rocket launch, its light structure is reinforced with three-dimensional curved surfaces. Solar cells have been placed on each side of the rover, arranged into a minimum area to avoid interference with other components. Mounted at a 70-degree angle, they maximize the amount of solar power generation. It adapts to a temperature range from -40 to 100 degrees Celsius. It is coated with silver and Teflon that reflect most sunlight and allows heat to be radiated into space. The top panel is thermally insulated by an Ultem resin spacer with low thermal conductivity. The electronics are mounted directly to magnesium heat sinks on the top panel to radiate its heat. The lunar surface is covered with regolith, a fine powdered sand. The rover can drive stably even when it is on a slope, returning with anti-skid wheels. And the link structure reliably supports the rover. It also detects obstacles with an infrared sensor. 4 cameras capture high-definition images in 360 degrees, which are transmitted to Earth with data compression technology. The cameras also detect the driving condition. To meet the challenges, Hactor has applied intensive problem-solving, using its multidisciplinary expertise to deliver a high-quality design solution. Overcoming extreme environmental factors, the team looks forward to completing the mission.
So that's a bit about our lunar rover for the Hakuto R project. And I just would like to end with a last slide. And this last slide is an invitation. We're currently hiring. We have more than 25 open positions. We're actually a bit desperate for engineers. So please, I invite the guys from the NOVA rover team to speak to us. And we're also looking for technological and strategic partners at the moment. At the same time, we still do have some space in terms of payload for 2021. So if you would like to send anything to the moon, please speak to us. And thank you very much for listening.
Thanks, Carlos. I think we should all feel very privileged to have seen some of those videos, so thank you for sharing those. Before we kick off with our question session, I just wanted to ask you guys all just a general question. So, you know, looking at the timeline of what you just presented there, Carlos, I mean, 2040, do you think that's a realistic time frame for sort of the big community, the Moon Village that you sort of presented there? Like, I don't know, naturally, I feel a bit like I'm very supportive, you know, of trying to achieve that. But I mean, as with all things, there are always technical difficulties and things that you didn't foresee, you know, that arise. So, you know, is there any leeway with that date or?
Well, we're strong on the vision, right? However, we know that, let's say on Earth, once you find a discovery of a deposit, it usually takes anything from 5 to 10 years to have a fully developed and operational mine. So from here to 2040, it's around 20 years. However, as I mentioned, I don't think we're going to have a full village with maybe 20,000 people, but we will definitely have the opportunity of see the first settlement of humans and start using resources in a very, very strategic way, like having these working pilot plants, you know, producing propellant and maybe some first materials for construction. So definitely, we will see a first settlement on the moon.
Any of you guys? Do you have thoughts on that?
I mostly agree with that. Definitely by 2040, I expect to see commercialization of lunar resources. So up to 2030 would be basically technology demonstrations and basically planning everything out. So an analogy to the terrestrial mining industry is doing all the drilling work, the exploration work, and then going into pre-feasibility studies after that. And the only factor that may play into the timelines is investment hype, because when you have, you know, a lot of hype being generated from companies landing on the moon, progress being made, that may accelerate things if you see a lot of investment pouring into the moon aspect of the space industry.
I guess I would just say it reinforces the idea that everyone has to work together on this sort of common goal, that if everyone has this vision and we get government, industry, everyone working on the common goal, then I think anything can be possible.
And yeah, just touching on that, with all this united efforts trying to reach out back to the moon, back to even Mars, it's almost instigating a new space race, and the implications of that could be beneficial or otherwise. But it's definitely exciting, and one of the unique aspects being a student is that, you know, we're progressing into an age where all of this is the future. That's the reality. So whether or not it happens in the timeline that Carlos was discussing, if that happens sooner or maybe even later, then that's something that we're going to be part of. That's something that we're all going to be a part of.
Good. Do we have some questions from the audience? I see lots of hands going up. So where are the mics? There's a lady down the front here, please.
Thanks for the presentation. You didn't touch on the very controversial nature of the ownership of space resources. Obviously, Luxembourg and the US have interpreted international law according to their own priorities around commercializing these resources and allowing for private ownership of them, if not the ground on which they are made. Could you just chat a little bit about the ethical implications of that? We all know, if we're talking about the lessons from the colonization of the New World, that what comes after a resource claim is usually having to defend that claim from other parties. And many of the navies of the developed world were developed in response to having to protect shipping lanes that they had formed and new markets that they had developed at great cost in the New World. How do you respond, given that the Moon Village Association is for everybody to have a say in these things, including the public? What do you say to people who believe we should not mine the moon, and that even a forum like this normalizes that idea and takes us closer to a dangerous future of war in space?
Okay, maybe I'll start. Thank you very much for the question. That's actually a very, very important, polemic, but very important question that we are addressing, not just iSpace, but a number of companies, governments, and so on. And I actually would like just to read the title of this group, which is quite long. Okay, so we are part of a group called the Hague International Space Resources Governance Working Group, right? And I always have to write it down. But pretty much it's a group made of governments where we actually had a meeting, I was part of it at the end of last year. We had the Russian government, Chinese, the US, of course, Japan, and so on, and the private companies that are intending to do some sort of commercialization with the moon. And the main talks, well, there are a lot of talks, but they're pretty much trying to draft what will be the regulations around space resource utilization. Now, as we know, there is an Outer Space Treaty and there's a Moon Treaty. Now, the Moon Treaty from 1979, right, it was not ratified by the main superpowers. It was not signed by the US, Russia, China, and so on, and Japan, because of 3 reasons, mainly. The first one is because that treaty was forbidding the use of commercial resources of space and the moon. The second one was that it forbids to put any sort of defense system on the moon. And the third one is that it's forbidden to alter the environment of the moon. But the main one is the use of resources of the moon. And because of those main elements, the Moon Treaty was not signed. However, we know that we as humans, and the question of, so to answer the first question is like we're working actively on those, on that part, because it needs to take everyone into account, and we, as I was mentioning, we do not have to make the same mistakes that we are doing or that we have done in the past. Now, what we're looking at the moment is the following, which is no one will be able to own a part of the moon, but we're going to be following something similar to what we do in international waters. For example, we are allowed to go into international waters, be on a place, and fish the fish, but we do not own that part, but we do own the fish. So right now, they're following something similar. Now, right now, it's what they call safety zones. What does that mean? That if you are a company that is putting effort, scientific effort, financial effort, and energy into exploring the moon for resources, you will be given by the UN, the United Nations, a radius, which will be your safety zone. And then within that safety zone, which will be delimited by space and time, there's going to be something else called priority rights, which says within that safety zone, there's going to be a section where you will be using those resources for commercial purposes, and you will have their priority rights to use those resources for a period of time. Now, as we know in the mining industry, when you are extracting metal and producing a revenue, out of that revenue, there's something called a royalty. And a royalty goes back usually to the place where that mine is being developed. And then there's another part that is called the tax, but that's of profit, and that goes to government. Now, so far we're speaking about some sort of royalty. And that royalty will be of the revenue. And that royalty, instead of being, the local place would go back to the good of humanity. But then the next question is, who are the space companies going to give that, let's say, 5% of royalty to? So far, the first answer is, well, it will go back to the UN. And then the UN will decide who to distribute that. And right now, the thinking behind is to pass that money to the countries that are developing their space technology so they can as well progress in space technology. And the next question is who within the UN? Well, that's still to see. And in the other question of should we go to the moon or to space and to use those resources, I think and this is my personal opinion, I think as humans, we're very curious and we like to keep expanding and traveling and so on. And in our curiosity, we will want to go further than Mars. At some point, we will want to exit the solar system and keep traveling. And what we do today is if we want to go from Melbourne to Brisbane, we do not fill one car with 1,000 liters of fuel. We actually go and stop every couple of hundred of kilometers and refuel the car and keep going. So one of the first answers of why do we want to produce propellant in space is to keep furthering our expansion and exploration activities. So if we actually want to exit the solar system, we will need to build space fuel stations, or pretty much going to the moon, refueling, going to one of the moons of Mars, refuel, go to Mars, refuel, go to Jupiter, refuel, and so on. And there's actually millions of asteroids that can have water around the solar system. And then we can come up with a pretty cool optimization system in what asteroids should we jump to and refuel and keep going. So my personal opinion is that in order for us to keep expanding and keep doing scientific exploration and so on, we will have to use resources. And the universe is vast and huge. Thanks.
Okay, so I'll reiterate what Carlos has said, which is to basically prevent conflict in space. It's highly dependent on progress being made in these international groups. About Australia specifically, though, because Australia is a signatory to the Moon Treaty, it makes things interesting. Regarding the Moon Treaty, if you have a look at the details, it's actually a lot more intricate than a straight, no, you cannot do this at all, because okay, I'll touch on the environment aspect. The specific wording it uses is that you have to take steps to limit environmental damage, basically. It does not straight up forbid any environmental impact at all, because then you can't even land anything on the moon. So that's one aspect. And also the ownership aspect, that's the important one that Carlos touched on. The interesting thing about doing a business is that you don't necessarily have to own something to sell it. You could sell a service. So in our specific instance, by focusing on the processing step, for now, basically, we don't claim ownership of any material that passes through the process. Instead, we're doing the work for basically a customer. And because the most likely customers are almost certainly not going to be signatories to the Moon Treaty, we're totally fine. And also, regarding this, basically, this whole services and whether we can operate within the Moon Treaty or not, I have received advice from Professor Stephen Freeland, who is Australia's leading space lawyer in this regard, that we're in the clear.
I'll try and address your last point, which was about how would we respond to people who say that they we shouldn't go to the moon, essentially, to mine resources. And I think that's a great question, just because this audience is obviously very focused on that one goal. And I think it emphasizes the importance of things like Moon Village Association to try and take all points in view and work towards a common goal, addressing all stakeholders, not just the nerds in the room who love space, essentially.
One of the lovely case studies or just examples that I like to bring up in terms of discussing, you could say the exploitation of planetary resources is looking at Antarctica. So Antarctica is not owned by any one country. It's instead a designated area of land that is inhabited by a series of research stations from all over the world. So it's a good example to illustrate how if we were to set up a base on Mars, it wouldn't be owned by any one group or conglomerate. It would be sort of divided dependent on who would set up that base, and there would be national research labs as a scientific outpost. But then on top of that, Antarctica actually has massive kilometre-thick seams of coal. So there is a massive amount of interest from mining groups all over the world who keep pushing, saying, oh, can I just have a little bit? It won't do anything. And then, oh, can I just have a little bit more? So it's a good live case study to look at how the communication between different countries, between industry, government, special interest groups, would interact, or how they are interacting with Antarctica. And then you can extrapolate that and look at, okay, if we were to take this and look at the moon or asteroids and comets as other planetary resources, how could we intervene? What protocols should we establish? How can we sort of guide that discussion and say, okay, this didn't work or this did work in Antarctica, let's carry that on over.
Great, thanks. Can I just quickly make a response to that? We should also keep in mind that under the Antarctic Treaty, there's a ban on mining for 50 years, if not longer. And Australia was really instrumental, along with France, in leading the world towards making that decision. So it's not impossible for us to actually do the same on the moon. And I'd also like to say, I love space too. And that's why I want to protect it. So I think we shouldn't say that only the space geeks who want to mine the resources love space. There are many different ways to respond to space and to express our love for it.
Yep. Just a final point about that is that the framework for the Moon Treaty was intended to be an interim solution. So given that Australia has now, at least within the agency, has indicated interest in continuing with this Moon Treaty, they're actually actively working on basically outlining the details in how you can economically use the moon and what are you allowed to do. So it's intended to be an interim thing that is changed in the future and much more likely than not for economic development rather than against.
I just would like to add to that, if that's okay. In terms of the Moon Treaty, we're still looking at it. Actually, one of the conclusions of the last meeting with the Hague International Working Group was that, and this was a recommendation from the UN, which is the Moon Treaty is actually really good. There's just a couple of parts that need to be defined better and constrained better in how this should be approached and for how long and how big and so on. So the Moon Treaty is still inside to just still be used and just modified a bit. Now the next part is, and we're not really thinking or planning to go to the moon and do and create some massive extraction operations. No, actually, if we think about it realistically, even though there's resources on the moon, it's in low concentrations. And a lot of these resources, like the water, comes from comet impact and asteroid impact. So in reality, what we are planning is to go to the moon, test the technology, and yeah, have some first fuel stations for pretty much travel, space travel, but the real future space mines will be asteroids. And asteroids that keep impacting with planets and moons and and so on. And for instance, the asteroid belt just after Mars is extremely rich in resources. And we're going to find anything from water, organics, metals, and so on. So the moon will be just a first step in testing our technology, but we are not really intending to have large operations, for instance.
Thank you, guys. I just want to make a quick point myself. I mean, what we're hearing here is that we have to mine with principles. And I think Giuseppe this morning, when he gave his presentation, obviously he said that principles was kind of integral to the future of any planning of humans and on the moon. So here on Earth, you know, when we look at mining, we obviously discuss a lot now mining with principles, and we look at risk factors in mining here on Earth. And the #1 risk factor for 2019 is the social license to operate. And obviously, intertwined with that is sort of how we environmentally manage our mine sites and look at their impacts and how we manage that waste material. So given that that's at the forefront of thoughts here on Earth, that's definitely something that's going to translate into any progress that we make outside of the Earth, on the moon and beyond. So I think also thinking about Carlos's new code, the JORC code for the moon, should we say? I mean, I very much expect a lot of environmental factors to be considered in this code that you'll be discussing with others.
Yeah, definitely. It's going to be taken into account social, environmental, principles, and so on. And as I was saying just before, we're in space, we're going to be developing completely new technology, completely new standards, and that approaches and addresses all these factors, of course.
Okay. Anyway, time to move on for some more questions. We've got a gentleman here, and then we've got one at the back there. So we'll take this gentleman, and then we'll take the woman at the back.
My question is to the rover team. I noticed in your video there, your vehicle has 4 wheels, and this new one, you've got 6. I wonder what the rationale behind the change is.
Do you want to take that one?
So the 4-wheeled rover was the 2018 one, and this is the 2019 one. Basically, 6 wheels just means there's more traction and gives you more stability on steep grades and navigating obstacles and things like that. And so in the video, if you saw it going over the log, it's able to maintain all wheel contact at all times, which the other rover will say couldn't do. We'll leave it at that.
Just as a great example, after this session, during the break, if you want to come down, we can show you why, as an example, we can move the wheels, and we'll show you the perfect example of why we've chosen the 6-wheel design, but more on that, how we've actually arranged the suspension, because the arrangement of the suspension and the wheels is actually incredibly critical to how the rover goes in different terrains. And if you look at all the different rovers from all around the world, from all the different student teams, there are so many unique ways that people have found a way to put 6 wheels on a rover. So yeah, come on down and have a look.
Hi, I have a question. So let's assume that colonization will be successful and that these companies will be mining the moon. As Australians age, about half of them have chronic health concerns. What place will there be for unions and OH&S in a capitalist society that's only there to mine the resources?
One of the unique aspects about the Rover Challenge and other robotic competitions is that the reason for it is always harm reduction and harm minimization and taking humans out of harm's way. So a great example for that is in relation to mining specifically. We were actually approached by the UK Centre for Astrobiology to develop a rover for them to go into the underground salt mines where it is extremely hot, it is extremely dangerous. Sorry. I've got to move my car. The whole focus is about taking humans out of dangerous situations. So whenever I talk about the rover to children, the first thing I say is, why do we want to use a rover in the first place? Why not send a human to Mars or to the moon? The main response they get is, oh, because you can die. That's exactly right. Humans can die. Rovers are replaceable. Rovers are expendable. You can send another one up for $2 million. You can't really replace a human life. So in terms of unions, I'm sure if we do set up bases on the moon, there will be infrastructure to support human expeditions. But the main goal is always to reduce the amount that humans would have to go out onto the surface, because if there is a potential for risk, the risk will happen. I think it's Murphy's Law. If there is something that can go wrong, it will go wrong. So the entire idea is to take humans out of the risk. But if, in terms of like the unions, I'm sure you guys can touch on that a little bit more.
Yeah, I'll just repeat the point, kind of, which is that the image of space mining is much different from the one you may think of when you think of traditional mining, where you have people, deep underground. It's very labor intensive. Whereas for space, that's really not possible because it's just too expensive, and also, as mentioned before, the risk factor. So almost all the mining and equipment would be done autonomously. As for the human safety factor, I believe there's already very good existing protocols developed by the big space agencies when it comes to safety of the astronauts involved. So I see no reason why that cannot be similarly applied for future commercial operations.
Yeah, definitely, and I would like to second on them. And this is the main reason in iSpace we're looking on robotics and rovers, because the operations will be 100% done by rovers and autonomous systems. And maybe in the worst case, we will have people on Earth still doing and sending some commands to the rovers, but mainly will be fully autonomous. Now, in terms of the health and safety concerns, let's say within the mining industry, we know there are still some big accidents happening on Earth. For instance, there was just a big disaster in Brazil with Vale and BHP, where a tailings dam, one of the walls just collapsed. And actually, some of the surveyors or people that were on the wall were taken with them, and 80 people and so on. So actually, one of the things we're actually working in iSpace is how can we transfer our technology of the rovers to the mining industry. For instance, instead of sending surveyors to the walls or to the benches after blasting, you can actually now send fully autonomous rovers with sampling systems, sensors, and so on, and to do the jobs that should not be done by humans anymore. And that's what I mean, that now the space industry has technology that can be transferred to the mining and earth industries.
I thought that was a really nice point you made in your presentation about that, the transferable technologies and how they can improve mining on Earth. So I enjoyed that. But that actually brings me to a point. In terms of like our traditional mining companies here on Earth, our BHPs and our Rio Tintos and Newcrest and so forth, how many of those are interested in this space? Do you guys get a lot of people sort of coming to you? And you guys, on the back of your shirts, you've got Boeing written down there. So, are they sort of thinking of, how's their development going in terms of thinking of getting, these things upscaled and onto the moon and so forth? So if you could talk about that.
In terms of an industry that is set to explode, is actually an industry that I'm really interested in is planetary mining, planetary resources, and looking at comets and asteroids as a source for minerals, rocket propellant, and just a stepping stone for further exploration. In terms of us getting approached, there is a bit of a miscommunication between academics and students and industry and government for that matter. In terms of looking at actually taking rovers and systems that are already developed and taking it to space, there is a whole system architecture and testing required that needs to be done, and in terms of like getting that progress initiated, that is the key area that needs to be focused on. One of the things that I like to look at is the NASA technology readiness level. So it's a flowchart that indicates at what stage the technology in its lifetime, and essentially when can we send it to space. And there's step 1, 2, 3, 4, 5. I think it goes up to 7. And the critical aspect where most technology either gets a thumbs up or thumbs down, let's say, to go on the Curiosity or Mars 2020 payload is, does it work on Earth? Does it work in space? And if it does, it can fly. And the inclination to always use systems that have mission heritage, or that means that they have success, is the sole reason why Mars 2020 looks exactly like Curiosity, because they know it works. So in terms of mining exploration, we don't know what works. So we don't really have any fallback to say, okay, let's send this. It's a massive area for development, and I think that's the main steps that people need to start looking at. Is if we are talking about mining, robotics, we first need to look at what works, and then looking further back about in terms of getting the technology started. It may be companies, it may be student teams like us who have a cool idea. There's a lot of steps that need to be taken and considered before we start thinking about let's send a autonomous rover that harvests silicates to the moon.
Okay, so big aerospace primes like Boeing, Lockheed Martin, they're very interested. It's part of their big plan when it comes to basically developing a space sector beyond the traditional satellite market. Now, when it comes to traditional mining companies, the story is quite different because while mining companies, even big ones, they take on a lot of risk. What they don't like taking on is unknown technical risk. So that's where, as mentioned earlier, the technology has to be proven to a certain level so that the major mining companies could de-risk the project technically, and then they would be much more interested in basically taking on the mature technology and bring that mature technology to market.
Exactly right. So maybe I cannot mention the names, but we have actually spoken to a number of mining companies and even oil and gas companies that have approached us as well. And it really depends on their strategic long-term plan of each of the companies. But the main thing that we have heard especially is that, yes, they're interested in us, but mainly to find applications of space technology into their operations, because they know that we have technologies that they can benefit from, and especially to benefit production, health and safety, autonomous systems, sensing technologies, and so on. And that's one of the chats I'm having actually next week with one of them.
Yeah, good, thank you. Do we have any more questions from the floor?
I saw some questions up at the back. The two kids. Did you have a question?
Oh, goodness me, that's my son. Come on, say something.
So how old are you? 8? That's fantastic. I saw you had your hand up earlier. Did you have a question?
When's the next time you think humans might go on the moon?
Good question. I like this question. I'd say between 2025 and 2030. So, 2028 or so, that's when.
That's right. So far, all the efforts have been pretty much pointed towards rovers and autonomous systems. In terms of when humans are going next, that's a good approach. Now, I was just reading in the news today that SpaceX is launching, I think tomorrow, their Crew Dragon, which is they're going to be the first private company to send humans to space. So, and this is the beauty of private companies, right? That in comparison to the state space agencies, we kind of like to fail fast and therefore learn fast and then succeed faster. And that at the same time, besides bringing technology and success stories faster, yeah, we will be seeing things like sending people to the moon or Mars way faster than we thought possible.
Okay, thank you, Cohen. So, do we have any last-minute questions? Are we going to be able to look at this over lunch? Are you going to leave the rover out?
Yeah, absolutely.
Yep,
Come
perfect.
down, check it out, lift some wheels up, do all of the fun stuff.
Okay, cool. So if there aren't any further questions, I think that's a good time for us to finish for lunch now. So I just want to thank the panel again, if everyone can give them a round of applause.
Yeah, thank you, guys. I think we're all very lucky to be able to have that conversation, to ask the questions that we have, and to hear such great speakers talk about their professions in that way. So we will break for lunch now. We have some great sessions after lunch as well. So get on the tweets, and they've got tickets still available to let others know. We've had such a great environment and mining panel. We are recording all of this, and we will get it up online at some point to be able to reach further audiences. So I think what's happening here is really great, and we want to communicate that. So please, up the back we have Space Association Australia with a table there. Go chat to those guys. We also have Kerry Doherty doing a book signing today over lunch. She's down here from World Space Week, so please go and purchase her book, and you'll hear from her later. And yeah, that's it. Thanks, everyone. Thank you.